Hi, everyone. Welcome to our webinar, Advanced Reinforcement, Detailing Below-Grade Foundations. My name is Mia Kay, and I am super excited about our webinar because today our speaker is Dave Brewster. He has over 20 years of experience as a rebar detailer and has a wealth of knowledge about detailing software. So let's get started. I'd like to hand over the presentation to Dave Brewster. Dave, please introduce yourself.
Thank you, Mia. Good afternoon, everyone. Hope everyone is staying safe and healthy. On the screen there, you can see my mug. It's not really a mug shot. That is one of my better shots. For most of you, some of you on the webinar already know me. For some of you that don't, there's sort of my repertoire of my past experiences. As Mia stated, I do have over 20 years of rebar detailing experience, both self-employed and with Harris Rebar. As most of you know, are aware of Harris Rebar, one of the biggest rebar companies in North America. In that time, 4.5 years of PT detailing experience, as well as the amount of software knowledge that has really brought me to this point. 30 years of CAD software experience, 25 of those years has been in 3D. And it'll come forth on why I made the jump to actually represent this software. It's just a phenomenal piece of software, and I'm really excited to show it to you guys this afternoon. There's my LinkedIn information, as well as the ALLPLAN, my ALLPLAN email, that if you want to email me directly, by all means, you can do that. Next slide there, please, Mia. We're 700 miles apart here, so we're going to have some little things here where Mia, there we go. So the agenda for this afternoon, the introduction, obviously, we're going to talk very briefly about current workflows and challenges. Going to get into the demo. After the demo is done, we're going to talk about who is ALLPLAN, and we're going to lead that into the question and answer period, and then we're going to wrap it all up. Obviously, the key important why you guys have come to see us is the demonstration part of this webinar. So, current workflows and challenges. Again, we're going to wrap this up. This slide represents challenges that are being faced mainly from a rebar detailer standpoint. The workflow, how do changes? We start with something, we get to a point, we have to make changes, we have to be able to track all that information at some point. So this is a workflow that encompasses what a detailer has to go through. Now, the same applies to engineers from the standpoint of doing that. So the idea of going forward of this demonstration is to touch on to the experience of both an engineering side, but mainly on the rebar detailing side and how we handle the information on that respect. So with that said, what we're going to do here is talk about the challenges, as I just stated on the last one, is the big takeaway from that slide is it is a siloed, segmented workflow that you're existing with now. Linking data to Excel spreadsheets, being individual DWG files, which can only hold certain parts of information. It can only hold so much information. That leads to what I call a segmented workflow. Our software better analyzes it, and it allows you to control that information. And as we start out this demo, I'll point that out to you. The project managing side of it as well gets very tedious when you have this segmented workflow. So we're hoping by the end of today's session, you get a quick sense of how our software helps with a lot of these workflow challenges that you're going to see, as well as from the productivity detailing enhancements. Thank you, Mia. So some key points. What our software allows is a focused 2D to 3D solution for rebar detailing. What you're going to see is a simultaneous 2D to 3D workflow. We're a BIM tool with extensive CAD functionality. The key here is CAD functionality, a familiarity to you to see why our software is different than anything else that's out there. We create efficient and quality construction drawings. Today, we don't touch on the deliverable side of it. We're concentrating more on the productivity side of actually getting information ready for that drawing sheet, but we allow for the efficient and quality construction of these drawings. High quality, reliable quantity takeoffs. Single source of data, meaning when you make a change in one location, it's tracked across the whole project. It's tracked across releases, it's tracked across bar lists, it's tracked across reports. So that's where we're able to do a high quality and reliable quantity takeoff of the information. Because of our background, our single source solution, we can remove discrepancies, we can better control RFIs, and we can look for conflicts. That's huge. Not only are we allowing you to detail, we're allowing you to have the ability to do some of the conflict. What we're also going to allow you to do is work efficiently between the designer and the detailer, better collaboration. When you get to the actual video, you'll see how we can start the collaboration start to happen just from a simple DWG file. And we have the open API and extensive libraries, meaning we can create more better parts inside of our software with having this technology available to you. Thank you. Now what you've all came to see, the demonstration of our software. Just to let you guys know what we've done for this demonstration. This is live. You can hear me stammering and going on and hear the excitement in my voice. But what I've done is I pre-recorded the actual demo portion of it. Let me just get the screen showing for you here. Okay. Because I've pre-recorded it, there's going to be no flicker. We find that when we do live demonstrations, sometimes there's a little bit of flicker, a little bit of a lag between. So what I've done is I pre-recorded. I'm going to talk you through this pre-recording, allowing me to pause at certain locations and go forward. It's about a 35-minute demonstration of our parts, of the aspects we want to show you today. But I think you'll enjoy the workflow and the ability to see this and for me to talk at the same time. So I'm going to go ahead and start the video here in a second. The key point that I mentioned earlier is this siloed workflow that you're used to, segmented workflow. Our software is a single source solution, a single source of truth. It deals with projects as a single entity. Inside that project, we deal with what we call internal drawing files. And with internal drawing files, this allows us to have a project in one location. We launch one project, everything to do with that project from one bar to one piece of concrete to one line is all in one location. So what you're seeing in front of you here is our drawing file setup. You can see how it's broken down. We have a couple different sides. One's more so for the laying out of the actual drawings. The other left-hand side is more how do we define our drawing file sheets. So every single one of those numbers that you see with the description beside it represents a single drawing file inside of our software. If you want to think about it as an internal DWG file, that's exactly what this is. So this allows us better control and capability with our software. So in order to start a project, because this day and age where everything is digital, there is no reason why you should have to reinvent the wheel and redraw something if it's already been done by someone else. ALLPLAN handles this digital information a few different ways. We can deal with rasterized PDFs, not ideal, but we can. But we do really enhance using vectorized PDFs, which is a print to PDF kind of file. And we also work with DWG files natively. What you're seeing in front of you here is an actual DWG file from AutoCAD, which will show line work, text, all the information brought in, simple drag and drop. Now we're ready to go. So in a matter of 2 seconds, I have information that I can start working with. So for the first portion of the demonstration here, what we're going to do is we're actually going to start laying out some of our concrete information for our model. We're going to use various techniques to do that. And you'll notice right now I'm just doing it in a simple 2D view. And I'm inserting what we call our 3D boxes. Okay? I'm picking in 2D plan and I'm entering in a value for the depth of those. These footings happen to be a 12-inch depth footing. So I'm going to go ahead and lay out a few of these. As well as doing these simple boxes, there are other ways we can enter in our concrete information, which you'll see in a second here. And we can do it with what we call Python parts. We can do it with elements. We have footing elements, slab elements, and so on. This allows us to very quickly get information here to start detailing, to start putting bar in. Now people say, do we need to work in 3D? And I'm going to explain to you why in a few minutes. Why is 3D so powerful? In the amount of time it takes me to actually generate this, which you'll see, having the 3D actually enhances getting information ready. What I'm doing here in the middle is I'm actually controlling, and I'm putting in a 30 deep inch foundation. And you'll notice in this foundation, there's a little area where there's a sump pit required. So again, I'm going to go ahead and I'm going to put in the where the sump pit is located, just using some simple tools. So with our tools, I can take any 3D object. I can go ahead and say, okay, where am I actually applying this? In my 2D view, I go ahead and I pick my boundaries and I give it a depth. So again, very, very exciting how this software handles any 3D information. So right there, another 10.5 seconds, I have this huge mat foundation with a sump pit. You'll notice there are a few footings here that require what we call a step footing. Our step footings, I'm going to build with one of our Python parts tool. Now, our Python parts, for anyone who's had any programming background, Python refers to a programming language. So what you're seeing in front of here is a pre-programmed, out of the box step, a detail of a stair where we can put it in. And this is the part about our Python parts is the dynamics behind it. And you're going to see that when I put in this step, or what we're going to call a step footing. I'm going to load in some predefined values that I've already set up. It's a couple 15-inch steps on this. It's got a slope already predefined. And I'm going to go ahead, and once I've loaded in my values, I'm going to place it in my drawing view. You'll notice that I have not even touched, I haven't even put anything in. I haven't gone into my 3D view and done anything there. I've done everything in my 2D plan. This is key. This is the exciting part about our software. It's a 2D to 3D workflow. I'm going to move this footing into its place, and then I'm going to launch back into the part, and you're going to see some grips that are going to show up. And these grips allow us to do dynamic modifications of our Python part. So you can see as I'm dragging these grip points, it's adjusting it in my 3D view as well as my 2D view. There's a couple of locations for this Python part, these step footings. I'm going to go ahead and copy those over to the locations and adjust them. As they're adjusting, I'm going to talk a little bit more about the Python parts. The Python parts, in this case, there was rebar. You can have rebar as part of your Python parts. It does not just have to be concrete. With these concrete and or rebar parts being dynamic, it's all visual. You can make these parts do as much or as little as you want and define them accordingly. And you can accomplish something that might take 20 minutes. After a part's developed, it might take you 2.5 seconds to do. So the productivity wise of using our Python parts is a twofold. Gets the information in quick, and it allows for modification after the fact if required. So Python parts is one of our dynamic tools that we have built into our software. We do have another dynamic tool that we're going to talk about here in a second after I've finished adjusting these footings. I put these footings in, it's got to do it. One little cleanup is some of these footings come in at a different height than some of the step footings in. I'm going to do a simple move command to get them into their location that's required. Perfect place to pause this. This talks about our CAD functionality of our software. The CAD functionality of our software allows you to use familiar CAD tools to continue doing what you need to do daily. There's no special 3D tools that are required to do a lot of this information. I can do a copy, move, mirror, rotate, all those commands. I can draw, I can stretch, I can use any one of our 2D commands to continue doing what you're doing and have a 3D object in the end. We always joke within our organization here, and we tell a lot of the customers that, you know what, think about it this way. You're doing stuff in 2D and you're getting a 3D for free. The way we look at it is we're not changing the way your workflow needs to change. We're allowing you to mentally do what you're used to doing. And as you're doing it, you're getting this 3D information. So I'm going to go ahead and continue and move these footings into place. So simple pick points, go ahead and move them down to where they need to be. So one of the things you'll notice is I do have some pad footings that haven't been put in yet, and this is on purpose. I could have put these in with a simple 3D box and done that, but I'm going to talk about our next dynamic part solution inside of ALLPLAN, and that's what we call smart parts. The smart parts do a couple things. work very similar where they're dynamic to Python parts, but there's a second part to a smart part that I'm going to talk about once we get to that stage, and that's connectivity between existing smart parts with the same designation. So just a little bit of changing between some drawing files here to open up some more and do that. One thing I do want to talk very quickly about with our drawing files, only drawing files that are loaded, which means yellow, and one being red, which means current, only that information is loaded into your computer's resources, meaning we're not very memory intensive when it comes to loading in information. You could have 500 different drawing files in a particular project, and with only 4 open, that's all that gets loaded in. So bear that in mind. We are very, very resilient to the fact that we can be very quick. So of these, for the smart part, what this smart part will allow me to do is pop in a footing with, again, very simplistic rebar. These smart parts can be as complex as you want or as simple as you want. For this one, I've just simply created a smart part that allows me to pop in a footing with some rebar at the bottom, as the schedule requires us to do. So when I place the footing, I place an insertion point. I'm going to do a square pad, and as soon as I place, you're going to see some points show up, and these points are dynamic, meaning if I click one of these points, it's going to adjust the rebar, it's going to adjust the size accordingly. And notice as soon as I pick the point, up there in the palette area where the pad name is 4.6, I built a little bit of stuff behind the scenes that actually does a calculation and will actually give you a pad name according to the pad size that you see in front of you. So as soon as I pick that point, you'll notice it's 7.5. Up there, the pad name is changed to 7.5. So again, this is a built-in part that allows for this. I'm going to change some bar size information dynamically on the screen. Please take note that the information is changing in front of your eyes. With the 7.5, I'm going to go ahead and place the other locations for that. So there's a couple more here. There's a 6.5 and a 9.0 that I'm going to put in. Again, please take note that as I'm adjusting this, the pad name changes. I'm going to change the number of bars required in each one of them, change the height. This is all done dynamically. And when I have these ones, if I put a 6.5 here, there's going to be a link between them that allows me to change something else that is very effective with using smart parts. So I'm going to pop in the 6.5 here. And then I'm going to place the nines. Again, dynamically pick the point, drop it using existing CAD lines. Everything changes automatically, just pad height, etc. And then it's going to go ahead and fix it accordingly. As part of the smart part, we do have the ability to do a rectangular with longitudinal number of bars and segmented. Again, we can have a smart part that is built with top, bottom, hooks, no hooks, chairs, all that. This is just a very simple way of showing you. So the next portion here is the portion of the smart part that is really exciting. It's exciting to see because if you think about what needs to be done, if there's ever a change, if you made a mistake, the F.5, 5.0s that you're seeing here may have had a mistake when they were putting in. This allows me to link these together and show a cumulative change. So this 0.5, this is where this stuff like this is why I get really excited about the software. This to me is the sizzle. This is it. So I'm going to go ahead and change the information. Number 7 bar, whatever is required in that footing schedule. And as I close out my changes, you're going to see the rest of them are going to highlight saying, hey, wait, you've got some more 5.0s. Do you want to update these? Yes, I do. And when I hit yes, each single one of those 5.0s are updated to that information. This allows for either a change after the fact or a detailing error or something along the way that needs to be changed. There is linkage between them. That is powerful. Can you imagine having a full plan of footings where you've got 40 of these laid out and going to each one of them and applying 40 different changes? If they're linked and linked properly, all 40 will change, but just by changing one of them. I don't have to go to a specific one. I can change any one of those and they will update. So for the most part, without me blabbering on and going on, we're 8 minutes in. We got most of our concrete in. There is some walls in here. There are some columns in here as well. I'm just going to show you a couple techniques here of very quickly getting the walls and columns. With the columns, I've already done the walls ahead of time, so I'm not going to dwell on it too much. But just by simply clicking an internal point inside this wall, you're going to see on the left-hand side a predefined height for this wall is already showing up just by selecting inside the CAD work. I can do the same thing for columns. I can find these columns. If they're already predefined, I can go ahead and pick an insertion point, and in the left-hand side there, you can see these 3D columns are showing up. As stated, I've already done the walls. I'm not going to need the walls, so I'm just going to go ahead and delete them out. So when I bring in my own walls, there's no clashes with what's there. So to this point, again, we reiterate, from the 3D standpoint, we are making you 3D aware, maintaining our 2D workflow. Why 3D? Where's the excitement? Why people keep asking, we don't 3D, we haven't been spec'd out to do a 3D job, Dave. Why do we need 3D? By doing this model once and creating this 3D information, what I'm able to do now is I'm able to create views and sections at any point that I want and put them onto my drawing area from a single source of my model. When we do rebar inside of our software, this is what got my attention into the software. This is what lit my eyes. They showed me this in October of 2 years ago, and as soon as they showed me this, within 5 minutes, I said, "Where do I sign up? How can you guys do this? Why do you guys do this?" Like, they couldn't explain it to me. I can't explain it to you. All I know is just it's so exciting to see, and in understanding why it does that and how it does it just blows my mind. So this next portion is key. When we lay out our rebar, we want to put the rest of the rebar in. We did some of our pad footings, we want to lay out our rebar. We work with what we call drawing views. In order to do drawing views, we create what we call plans and sections of our model. So what I'm doing right now is I'm creating a plan view over top of my quote unquote 3D model, okay, that I'm looking at in 2D, and I'm going to create this plan view. From that plan view, I'm also going to pop in some elevations. What we do is with the reinforcement in our software is we work with, a couple different views in order to get that information into its location in a 3D model. Now, if you think about this, I'm going to be detailing in one view, I'm going to shape my bar in one view, I'm going to place it in another view, and magically, through the power of our software, it throws it into the 3D model at its location. When you do that and all your views are linked, whatever view that rebar needs to show up in that will show up in the view that it's associated to. This is the power behind our software. This is what really got me excited about it, and I couldn't understand. I said, where do I get signed up? I mean, this is it. So what I'm doing here is I'm popping in some elevations. Again, you can see one model. I can make as many elevations, many sections as I want to start putting in my rebar. We're going to concentrate on the east elevation of this particular project to show you some of our reinforcing tools. And in order to do that, I'm going to pop in a section cut through the wall itself so you can see the bar going in from section. So with this, the rebar, what happens is we place rebar similar to what you're used to, is through our quote unquote our manual technique. And with our manual technique, you're going to see our enhancement tools of putting in rebar. Is you're going to see that by placing this bar in one view, or excuse me, shaping in one view, placing another, is going to appear in whatever views I place it in, as well as in the 3D model. And we're going to use existing tools, or our existing line work on our quote unquote concrete to apply covers and so on. So what we're going to do in this next area is we're going to apply some our longitudinal bars in the bottom of our footing. Dynamically, we can change information. We can change cover information. We can change the size of the bar, bending pin factors. There's a lot of information we can change about the bar. In this case, we're going to do a simple straight bar. And the straight bar we're going to place is going to be along the bottom of the footing itself. So you can see here, what I'm going to do is I'm going to pick the first point, end point. From the end point, I have a -30 projection into my footing. And you're going to notice this little blue and green area. I'm just adjusting some cover here. I want to give it 3.625, which is 3 5/8 in the bottom of the footing. Cover it starting at the bottom, and I'm going to increase my embedment 48 inches. And you'll see this green and blue. This represents a lap location. So what I've done is I have predefined as part of this particular project what my maximum stock length bar is. Now it's an overall stock length, which means every single bar for this particular one, number 3 through number whatever, is going to be, I believe I set this at 30 feet. So any time when we're detailing a bar and it gets past 30 feet long, it automatically knows to add another bar to not extend past that. So I'm changing the lap length for that to 30 inches because that's what they specified. And now I've gone ahead and I've got a 30-foot bar and whatever the remainder is. As I'm putting this bar in, it's asking me to label it. You'll notice in the label, the number, the quantity is set to 0 because all I've done to this point is I have simply shaped the bar. Next portion of this is place the bar. Where do I need this bar to go? So with this bar, I shaped it and I'm going to place it in a footing in its location here. By having the align button clicked off, it knows where to throw it into the model in my plan view. That's not my 3D model, that's my plan view. I'll change the number of pieces to 5. You'll notice that the labels, after I put these in, the labels on my other elevation have changed to show the proper number. Instead of 0, they'll now say there's 5 pieces. So at this point, I'm going to show you the excitement. This is it. I mean, I've done this in 2D. I haven't changed the 2D workflow. For all you know, I was doing it in 2D, but now look at my 3D model. There's my 3D bar at the location that I've drawn in my 2D sections and my plan. This is what really got me. This is the excitement. This is the excitement I want to share. This doesn't, to me, I can't fathom how a software can actually do what you're seeing. So what we're going to do here is, now that we've got this in, okay, we're going to place another tool here. And if you have what we call special shapes in the case of, you know, that simple straight bar, let's say you want to put this in. When we put in special shapes in here and you want to shape your bar as you go, we use what we call a free-form rebar, okay? So you'll see it come up here in a sec. This free-form bar allows you to pick points, and as you're picking your points, it's shaping the bar as you go. And we can define information as we go. We can look for intersecting points by using our snaps. We can do a point of intersection, let it find it, and then we have to reverse where that bar needs to go into the concrete. So we're going to pop it into the concrete there. Now, at no point have I put in any values. You'll see here we have 3 segments to this particular bar. Each one of those segments can have different covers from that piece of concrete that I picked. So I've got 3 5/8 for the first 2, and I'm going to leave the last one at 5 inches. I need that to be sort of mid-concrete, okay? As I do that, as I define that, I'm also going to say my last segment needs to be exactly 30 inches long. Now that's done. Now I'm going to go ahead and place the bar. I shape the bar. Now I'm going to place the bar. One thing to keep in mind, at no point during this did it ask me what shape do I want to place. It didn't ask for an ACI shape. It didn't ask for any of that information. Our software, we already have predefined the standard ACI shapes. So if we draw a shape that's recognized as an ACI shape, say T1, T2, S1, as you draw it and add hooks and remove hooks, it's automatically looking in the background to see what shape you've placed. So this is another sort of mind blower that, you know, hey, we have the ability to do that. We can also work with custom shapes where we can assign information to each one of our legs. We can do that. But as long as it's a standard ACI shape, it's going to recognize it as that. So now that I've placed the bar, I've shaped the bar and I've placed the bar, it's gone ahead and put it in its location. You'll notice here I can change the number of pieces dynamically on my screen. What that means is I can highlight the bar and I don't have to go back into anything else, the properties of the bar or nothing. I can change the number of pieces. I can change the diameter of the bar just by highlighting the bar in my view. And you'll notice that the label changed over there from 5 to 6 pieces. Change it back to 5, the label changes. Single source of truth. Whatever view I change it in, whether it's a 3D model, 2D view, 2D plan view, or elevation, it changes across the board. All this is data driven. Each single one of these pieces has what we call a unique identifier. It can be tracked from the time you make it to the time it's being poured into a piece of concrete, if you so choose to do that. So the next little fancy tool we're going to talk about here is our free form or excuse me, our sweep along a path. And this is another productivity enhancement tool. You'll notice just a lot of the things we're doing right now. I haven't had the need yet to draw a construction line. I haven't had the need to do anything. I haven't had the need to offset a line to figure out how far my bar needs, how tall my bar needs to be across an embedment length. I can use existing information to use our rebar tools. So productivity-wise, just using our tools, productivity-wise, our quote-unquote manual techniques will already make you more productive. And I haven't even said, you know, hey, oh, and what? Guess what? You get the 3D model. 3D model is free, guys. We're still doing stuff in 2D. So I'm going to go ahead and next tool we're going to talk about is our sweep bars along a path tool. It can be used on curved walls. It can be used where you've got some real funky stuff where you need it to calculate a lot of different varied length bars. We're going to make it a little bit more simplistic and show you the abilities of a sweep bar along path just to put in some footing dowels. So the first bar I placed here was a dowel. The next bar I'm placing here is my transverse bars for my footing with my setting. At no point here, you reckon, if you've noticed, at no point here have I placed the bar. I've simply drawn the bar. So I'm setting this up for this next tool. Now that I've drawn the bar, I've actually shaped the bar, now I want to do a placement of this bar along the footing, and I want to follow the step. I want to make sure my projection above each step is the same. It's 48 inches. Now, we talk about construction lines. I haven't really had the need to do any construction lines, but I am going to do two things here. Is I'm going to draw what we'll call a 3D line. And the reason why I'm drawing this 3D line is I need a couple paths to follow. I can use existing line work on my 3D object to select and create and generate these paths, but that would require 4 or 5 different picks to pick all the way along. Whereas a simple drawing 2 lines here, which takes 30 seconds, I'm setting this up for an experience you're never going to forget. Let's put it that way. Just all joking aside, what I'm doing is, if you think about what you're going to see now and the amount of time it would take you to draw this, or even from a detailer standpoint, to do my bars all along this footing, I've got a step footing, I've got different ones, I've got a thicker footing in one location where I need my dowels to be a little bit longer, is I'd have to probably put in 5 or 6 different ranges and different bars and copy and stretch and move and do all that to get that information. I'm going to show you here how I can take one bar, sweep it along these 2 paths, and just like that, I have my bars going from the whole length of the wall, going up my slope at my steps. It knows my step location. It's made sure I maintained a 48-inch embedment or 48-inch lap into my step, into the wall above. Now that is along that whole length. So a couple little things, I'm just going to do a couple little cleanup. That represents one bar mark. I'm going to change a couple bar marks on these just so I can show you doing going forward, show you some of the varied bar sets. So what I'm working on now is I am changing some of the bar marks for these bars. So right now you can see that's the whole length. If I did a simple stretch at this point, it would have changed the bar marks automatically, but I like to do it a little bit ahead of time. I like to do my cleanup first rather than afterwards. So what I've done is I've segregated some bar marks to be different. You can see that's now a different bar mark. And what I'm going to do is, I know these need to be longer. I can do a simple stretch tool from the bottom, but sometimes I catch certain bar I can hide. Techniques. I'm telling you one way, the other way is doing it. What I'm doing here is I'm move the bar down to its new location. Cover is the same from the bottom, and then I'm going to stretch. Now the first attempt at this, I caught the footing by accident, so I'm going to do the stretch command one more time here and make sure I don't catch that again. Just knowing where to pick is sometimes benefit. Using our tracking tool, I can stretch this up, track over from the top of that one, and I've got the exact same length above that. So now I very quickly, again, without the talking and without doing all that, you can see how quickly I can put all my dowels along that length with my different ranges and have this ready to go. Now at this point, from an engineering standpoint, you would leave it as this. From a detailing standpoint, we would only want to show single bars, okay? Single bars for each run. And with these single bars, we want to, I mean, this is good, doesn't really help us in the field, but we now want to apply some information to these bars. Where's that bar's data range? Where does it start and stop? And what is the label of that bar? You know, what are we looking for? So I'm going to go ahead and pop these bars in. Okay. And then from this point here, I'm going to label it. We have a lot of different label options. You can see I'm picking from a list here of predefined notes that I can apply to the bar. And I go ahead and place the label. And then I can do it with all the ranges. So with that, go ahead and place the remainder of them. And we have, again, tools built in that really help you and enhance how we place our information, excuse me, our labels here. Is we can turn on leaders on and off. Automatically, if I pick something, it knows to put in a location, and it puts in a little dot to point to that range. So again, I can very quickly go and do the rest of these. And I'm detailing as I'm going. So I've generated the bar. In this case, sweep bars along the path, you detail after the fact. The best part about our software is we do not force you to put in a bar, label, go back, make the changes. You can put in all the bars you want, change the ranges, change whatever, go ahead and label out the fact. In my opinion, you are actually more efficient doing that way because you can be more controlling what you're actually doing at that point. So now what I'm going to do is I'm going to take this transverse bar and I'm going to also sweep that along the path. Okay, so at this point here, we're going to take it and sweep along the bottom path. I don't need the step in this particular one. You'll notice with this one, I put in all the bars. Now I know I don't need them in the deeper part of the footing, so I'm just going to go ahead and remove them. Right now they're part of one range. By removing what I need to remove, it splits the other ones up into separate ranges. So nothing is stopping me from saying, well, if you want the other bars in here, you got to change the other range of the other one and then create a new range for the ones you want in the middle on either side. Do it on one shot, erase, move whatever you don't need, and you've automatically generated more sets just by doing that. And you can see in my plan view, the bars show up and so on. So when we also do a label, I can label after the fact. Again, with automatic labels, as soon as I pick on a label that is shown in a dot format, it automatically, again, I'm just showing you something simple here, it automatically puts a circle around. It knows I pointed to a dot and not pointed to a bar in plan. So, some of these little things right into our software that allows you to be a little bit more effective in your detailing, which is really key. So you can see here all this 3D information. I could turn the 3D off at any point here, and you honestly wouldn't even know you were detailing in 3D. We're doing everything here in our 2D views and whatnot. So one of the other tools we're going to talk about here is our area reinforcement tool. It's sort of a one step up from, it's an automated tool, but it's not a dynamic tool. It's not like a Python part or a smart part, but it is an automated tool. It's going to very quickly allow me to put in formats of bar in this depth footing, the 16 depth footing. So I'm just adjusting some variables here that will allow me to set this up perfectly. You can see in my two views, I've got what it looks like. I can change the orientation. I can change the size of the bar, spacing, all that information I can change. Label it as I go. As I pop in the label, change the label information, customize it, text as you go. Do you want it to be a bar mark, straight bar mark, no mark, whatever? It can be adjusted. We go ahead and place that in. The power of this particular tool you're going to see in the next spot is the ability to what we call match. When we do a match, it looks for an existing area reinforcement. When you pick on the bar, notice that the cover is automatically adjusted to the bar size, so it's bumped it up into that. Automatically turns it 90 degrees. I go ahead and place my dimension. I place my bar and so on. This is a tool that's built into ALLPLAN. This is not a macro. This is nothing. This is built into our software. So the ability to do this just out of the gate without any user intervention to modify it is really a good thing. So I'm just going to change the number of bar for the top and bottom and change the spacing. And you'll see here that I'm now working on the upper, still all within the same tool. I haven't exited the tool once. The bar is placed in the same location. And from that same location, I can go ahead and change a couple notes, and I'm going to now match the other side, going the other direction for my top, and magically I get the other one. So what you're going to see here in a minute is I am going to adjust the placement of the top and bottom location of the bars, but you don't necessarily need to. In this case, this may be good enough. I've labeled it, I've shown where it needs to go, the range it needs to go, and I'm done. For a little bit of cleanup purposes, I can actually move the display of the bar. The bar itself, if I did a simple move command of the bar, it is going to physically move the bar, meaning it moves the 3D or it moves the bar. By moving the bar display, this moves the representation of the bar. So I'm moving the representation of this bar just a little bit so you can see there are two different bar sets there, and I'm going to do it for the other one. Okay. So at this point here, you'll very quickly see that I've got my 3D bar, or excuse me, my 2D representation in my views. I've got top, bottom bars, I've got layering, got everything offset. 3D views, there's my pretty 3D picture of the map bars that I put in. So again, I mean, we've been talking, this video has been running for nearly 28 minutes. In 28 minutes, I've got a lot of information. I've got a detailed set of drawings to start for my elevation on a video. I've got some map information. I've got it done in plan. And it's a single source. If something changes on one, it's going to change across all of them. I don't have to redo anything. I don't have to go to one view, change it in there, go to another view, redraw it. If I want to redraw something, I redraw it in my original model or one of those views, and it's going to update across the board. This next tool, I'm going to show you a Python part rebar tool. We talked about a Python part for concrete. I'm going to talk about a Python part for rebar. So what I'm doing is I'm going to very quickly throw some rebar with our rebar opening around an opening in the concrete. So this tool very quickly allows you to throw rebars. I just threw some diagonal bars. I picked on the opening in one of my elevations, intelligent enough to know how deep that concrete is there. So it's going to adjust the U-bar depths and everything accordingly. Now I've changed some settings, some lengths. I'm going to go ahead and close this, and there's my 3D bar. While I'm talking, I literally did an opening with U-bars, diagonals, and I can change the length in probably 30 seconds, not even. I've adjusted, I put that in. That's a Python part tool. That one is, there is dynamics to that. That's what the Python part does. And at the same time, it's created an automated tool, something you're used to doing. That's one of the various out-of-the-box Python part rebar tools that we have. We have columns, we have beams, we also have corners for certain situations. What I'm doing next here is I'm setting this up for adding information to the bars. And we're gonna talk about releases and bars and so on. All this information, this is the easy part of this. Once the data is there, putting this information to it is easy. So what I've done is I've copied the view by simply copying the view and changing what I want to see in that view. I didn't have to redraw that again. I copied it. It takes the information from the view, all bars, and then I can go into each view and hide what drawing files I want. So if a drawing file contains rebar, text, all that, I can hide it very easily in 2 clicks. So in one view, I've got all my footing bars. In the view above that, I have my wall bars. For the wall bars, I could have been a little bit more precise and used the area reinforcement tool, but I didn't in that particular case. So what we're doing now is just pause it for 2 seconds here. What I'm going to be doing in this next portion is we're going to talk about, now that we have some information for the bars, we're going to talk about how do we see different varied bar marks, how do we see, how do we assign, let's say, prefixes to bars and assign release information. So we got about 4 minutes left here, then we're going to open up some questioning. So here, what I've done is I'm picking on some varied bar sets or tapered bar sets and showing that I can very quickly extract that information for the purposes of either putting into a spreadsheet or sending to someone to build. I can extract that and send it. I can also pull out a ACI rebar legend. And what this rebar legend allows you to do is it allows you to very quickly pull up the bars associatively. So any bar that exists right now, I can pull up exactly all the bars that exist in these open drawing files, and I can list them out. I can show you the bar size. There's my ACI shape codes 2.17.0. It shows all the varied bar marks if you want them in that particular list. And I'm also going to show you one I've sort of developed, which is more recognizable to a rebar detailer sense, which allows for release information. Segregate the bars by releases. So you'll notice as I first bring this in, the bar list is empty. So I'm going to go ahead and place it. Once I place this, I'm going to go ahead and assign some releases to the bars themselves. Again, this is some of the stuff that just opens my eyes that as I'm applying information to this data is linking across everywhere, single source. This is key to our software. I'm going to go ahead and assign some release information. I've set these up a little bit ahead of time so we don't have to go through them. Release 111, which has some defined release ID, the footing, and the rebar prefix. I'm going to apply it to all these footing bars in here. Pick a window around these, go ahead and assign that information to those bars. And you'll notice a couple things. All my labels are automatically going to add the prefix to them. The 5, which said 5 before it, now is a 5A001, so prefixes have been added. And if I update my tables here, you'll see release 111 now exists down there at the bottom. What I'm going to do now is I'm going to assign release 222 to my wall bars. And you'll see dynamically how this dial or my release dialog box down there, my release bar list is going to update. So 222, I'm just going to change the release description here to walls. And then from my walls, I'm going to go ahead and apply it to all my wall steel. And I'm also going to include the Python part wall steel. It's going to pull the wall steel out of the Python part, from the Python part out of release 111. You'll see that update down there. And you'll notice that I now have a release 222 bar list showing up automatically. Okay, so this particular bar list segregates amongst releases. What it allows me to do is any information being dynamic is now linked into those sheets. For the purpose of time, it's going to increase this a little bit here. So at this point here, I just want to show you how these become dynamic. Okay, the bar list. I've got a number of pieces here. You'll see on the left-hand side as I adjust the number or the spacing for this particular one. You'll notice over here the number of pieces is going to change to 100 to 110. If I change the spacing again, it changed to 93. Everything is linked. Single source of data. So if I change in one location, I could change it behind you, I could have changed it in elevation, I could have changed it in 3D model. Everything is linked to it automatically changes. So one last thing I want to show you here is pulling up data from a bent bar and how that bent bar, pulling out what we call the schema of that bar will allow you to change the bar again. Everything is linked, so not just the information, the number, also the data behind the bar. Now I stretched it first here. I didn't quite stretch it enough to make a full change. I meant to stretch it 3/4 of an inch instead of a quarter, but I'm going to stretch it. You'll notice here that I've got now changes here, and in my bar list, the update changes. So again, it's exciting to show you this stuff. It's kind of hard to, kind of compress this down. I could sit here and honestly, I could show you for 4 days straight the information, how to get this to you, but I want to pique your interest. This is the idea, is piquing your interest. So that concludes the portion of the demo here. I'm going to pass it back over to Mia here to start a slideshow, and then we're going to open up for some questions and answers. Mia?
Yep, I'm attempting to do that right now. Just give me 1 second.
Yes.
Okay. And okay. Go. Oh boy. All right. So we're gonna I'm just gonna let you finish up and then we'll go to our Q&A. We have some questions. So I've got them already. I can read them to you when you're ready. So
okay. So with these slides, we'll breeze through this quickly. We're leading AE software. We've been around for 30 years. We are not a new software. We are a software that has been in, out there for the world to see. The reason why North America hasn't seen it is we are newer to North American market. So, we're really excited. We have a team that is excited about this whole thing. So we're not new. That's the key. We're a comprehensive solution for rebar detailers, engineers, and contractors. The BIM part of it is sort of a bonus for you guys. We're the founders of OpenBIM. If anyone know what OpenBIM is, we are the founders. It started with ALLPLAN and with Nemetschek company. We have 400 plus users across 9 countries, and this is the key fact here. Over 240,000 users in 41 countries and 20 languages. This is to tell you we didn't just start up yesterday. We have been around. This is key. 240,000 users can't be wrong. So we're excited to show you. See some pretty 3D pictures. Next slide, please. So you see some pretty pictures there of rebar that's actually done inside of our software. This is for the, impress the friends and family. That just tells you what you can get from our software. Key to our software, as I stated right from the beginning, a single source of solution, a single source of truth, project-driven file structure, accessibility, and managing data. Go to one location, all your drawing files are there. Someone needs information on any specific bar in that, we know where to get it. We allow for this to happen. We can manage the project better from being a single source. ALLPLAN Share allows you to have multiple users on one project, and we can lock information out. It allows us to, especially with the day and age of what's happening in the world, ALLPLAN Share is key of allowing people to work from home on a similar project.
And just to conclude, I'd like to say, I should let Dave say this, but I'm already talking. Dave is happy to answer any of your questions. His email is very easy, dbrewster@allplan.com, his phone number, and you can contact him anytime with questions. He'd be happy to do a personalized demo for you if you're interested. So do keep in touch, and please register for that next webinar. I think this will answer a good deal of your questions.